This is the second lesson of Unit 15. So in this lesson, we are going to discuss some situations that we are going to change the molarity of the solution. Okay, there are three situations that we are going to discuss in this lesson. So situation 1, there will be some direct change to the solution, and those changes are just physical change, so there are no chemical reactions involved in those changes. Okay, so here it gives you a table. Okay, it lists out some of the actions that may change the molarity of the solution. Okay, the molarity may remain the same. Okay, so I want you to fill in this table using the sign given here. If there is no change to that substance, for example, no change to the number of mole of the solute, then please use the dash to represent it. If the number of mole have increased, and then please use an arrow pointing upwards. If the number of mole of solute have decreased, then please use an arrow pointing downwards to represent them. So please pause the video here, read all the actions, and then think about it and try to fill in this table before I explain it to you. Okay, now let's go through the table together. So in the first case, we have adding water to the solution. Okay, so first, let's consider, is there any change to the number of mole of the solute? Okay, here we only add water. Water is a solvent, okay? There is no direct change to the solute, so we can write a dash to represent it remains the same. Okay, and then how about the volume? Okay, we're adding more solvent to it, so the total volume of the solution should increase. Okay, and then how about the molarity? Remember, the molarity is calculated by dividing number of mole over the volume. Here, the number of moles stayed the same, but the volume increased. Okay, so the molarity should decrease. Okay, using a very simple example. Okay, if you have a solution, okay, and you find it's too salty, what are you going to do? You're just going to add more water to it to dilute the taste, right? That's what's going to happen for the first action. And then let's move on to the second one. Part of the solution is withdrawn and poured to a small container. Okay, so if we take a small portion of the solution, that means we only take some of the solute out. So the total amount of solute in the sample actually decreased. Okay? And then, again, because we're only taking a small portion, okay, either withdraw it or put it into a small container, that makes the total amount of the solution that we are taking away also decreased. Okay, and since the number of mole have decreased and the total volume have decreased, actually there should be no change to the molarity, so the molarity should remain the same. Okay, again, if we use a real life example, it's more clear to us. Okay, if we have a large bottle of Coca-Cola, let's say 1 liter of Coca-Cola, and we only take a part of it, okay, it should taste exactly the same as the one that we stored in that 1 liter bottle, okay, because the molarity is the same. Okay, so that's for action 2. Then let's take a look at action 3. Add more solute to the solution. Okay, add more solute to the solution. So here we have direct change to the solute, so the number of mole of the solute should increase. And when we are adding the solute to the solution, actually there will be tiny amount of change to the total volume. And this part we just ignore the change, okay? Because in grade 7 you have learned molecules, they have space in between, and actually when we dissolve those solute in, okay, they can fit into those spaces. So overall the change to the volume is it can be ignored, okay? So here, if we have increased the total number of mole but the volume stayed the same, so we should expect our molarity to increase as well. Again, using real life example, okay, when we are order a hot milk tea in a restaurant, and you after you taste it you think it's not sweet enough, so you're gonna add more sugar in, okay, and then you taste it, not sweet enough, you add more sugar in it. So as you increase the amount of sugar you put into your milk tea, the molarity of the sugar, okay, in this solution actually increased. That's why it becomes sweeter and sweeter when you taste it, okay? And the fourth one, okay, here it tells you the outcome, okay, and asks you to predict what action have been taken in order to make the total number of solutes stay the same, but the volume decreased, okay? And because the total number of solute remained the same, but the volume decreased, so we should expect our molarity to increase, okay? So in what case we have no change to the solute, but we can remove some of the water, okay? So here the answer is very simple, so we can just boil the solution so the water will evaporate, okay, and the total volume of the solution should decrease. Okay, so that's for this table. This table is just to help you to understand the changes to the molarity. Okay, there is no need to redraw this table when you are doing questions. Okay, so let's move to the examples and go through them together. So here, if I boil 500 cm cube of 1 molar of sodium chloride solution and change it into 200 cm cube, okay, so originally we got 500 cm cube of 1 molar, but then we boil it, so the volume changes to 200 cm cube. So what will be the final molarity of the solution? So again, if we want to work out the final molarity, okay, so we need to know the number of mole, and then we need to divide by the volume. And in this action, because we are only boil the water, which is the solvent, okay, we didn't change the amount of the solute in it, so we should be able to write this key equation here. So please use your highlight pen to mark it down, and this is very important. Okay, so if there is only physical change to your solution, okay, no chemical reactions involved, then your number of mole of the solute before your action should equal to the number of mole of the solute after your action, okay? There's no change to the total number of mole of the solute. However, because the molarity and the volume have changed, so we could calculate we could use the different number of mole and the volume to work out the number of mole of solute at the beginning and the number of mole of the solute in the end. Okay, so that from that equation we could turn it into here. So number of mole equals molarity multiplied by the volume. So at the beginning it should be the molarity, which is 1 molar. Okay, and for the volume, remember it gives you in cm cube, you need to convert it into dm cube first. Here you need to do that as well. Okay, so it should become 500 over 1,000, so it will become 0.5. Okay, so if you multiply this two, then we will be able to work out the total number of mole of the solute at the beginning. Okay, and then for the total number of mole of solute after your action, then it would be the one that we are looking for, the molarity of the solution in the end, multiplied by the volume. The volume is already given to you, 200 in cm cube, so if we divide by 1,000, it will become 0.2. So by solving that equation, we will work out the molarity in the end will be 2.5 molar. Okay, so that's a simple way to calculate it. Okay, but of course you can do it stepwise. You can work out the number of mole and then divide by the volume, but it will be much quicker if you can memorize this key formula, okay, this key equation. So let's take a look at the checkpoint questions. Again, please pause the video here, attempt the question by yourself, and check your answer with me. Okay, let's take a look at the first example. Remember, always use different color to help you to distinguish the numbers that are given to you. Okay, so first, 50 cm cube of water is added to 50 cm cube of 1 molar sodium chloride solution. So what is the concentration of the resulting solution? So at the beginning, we have 50 cm cube of 1 molar solution. And what is the action that we take to change the molarity? Okay, we add 15 cm cube of water in it. Okay, so after we highlight the information, then you need to be able to circle the parts and you need to do unit conversion. Okay, cm cube into dm cube. Okay, and then you can start to do your calculation. If we want to work out the final concentration, then we must work out the number of mole and the volume. Okay, so let's do the number of mole first. Number of mole should equal the molarity multiplied by the volume. Okay, so the molarity going to be the molarity that provided molarity of the solution at the beginning. So it's 1.0. And then multiply by the volume, 50, but we need to convert it into dm cube, so we times 10 to the power of minus 3. And then that will give us the answer 0.05 mole. Okay, and then we need to work out the final volume. Okay, so we use a subscript of F to represent the final volume. And it should equal to the volume that at the beginning, okay, and plus the volume of the water that we add in. And remember, you need to change it into dm cube, okay, so times 10 to the power of minus 3. Okay, so that will give us the answer. So final volume of the solution should be 0.1 dm cube. And then from here, it's easy for us to work out the molarity. Molarity should equal to number of mole over the volume of the final solution. So it would be 0.05 over 0.1. So the final molarity, okay, better write the subscript to represent it. Final molarity should be 0.5 molar. Okay, again, always have the unit attached to your final answer. Okay, so that's for question 1. And then question 2. Here, we want to dilute 500 cm cube of 5 molar sodium chloride solution into 2 molar. What volume of water should be added? Again, highlight the information. At the beginning, we have 500 cm cube of 5 molar sodium chloride solution. Okay, in the end, we want to change it into 2 molar. Okay, so remember the equation that we have used here, I highlighted. Okay, so because the number of solute remain the same, so that we could use this and work out this equation. Okay, so we apply that equation here. And before we start calculation, remember always do your unit conversion first. Okay, so you should be able to write, molarity initial multiply the volume of initial solution should equals the molarity of the final solution and the volume of the final solution. Okay? And then let's substitute the numbers in. Molarity of the initial solution 5.0 and the volume 500 over 1000, then it should be 0.5 equals the molarity of the final solution is 2, and then the volume of the final solution. Okay, so by solving that equation, we could work out that the volume of the final solution should equal to 1.25 dm cube. Okay, so from here, you should notice that the final solution is a combination of the previous sodium chloride solution plus water. And here, the question asks you to work out the volume of the water that added in. Okay, so this is not the final step. You need to do one more step to work out the volume of the water that you add in. And the volume of the water that you add in should equal the volume of the final solution minus the volume of the initial solution. Okay, so that will give you how much water we've added in. So it should be 1.25 dm cube minus 0.5 dm cube of the initial solution. So it will give us 0.75 dm cube. Okay, so that's the amount of water we have added in. Let's move to the situation 2. We are going to mix 2 solutions together. And remember here, we're mixing 2 solutions that will not have any chemical reactions. Okay, so for those who are going to have chemical reactions, we're going to discuss it in situation 3. Okay, so take a look at the example here. We have 2 sodium chloride solution. Okay, so at the beginning, they look exactly the same. We put 0.2 mole of sodium chloride in, and then we put 0.4 dm cube of water in, and we make it 0.5 molar for both beaker. Okay, and then we add them up and we put them into one single beaker. So the resulting sodium chloride solution should contain, of course, the total amount of solute should be the one in the first beaker plus the one in the second beaker. So the total amount of solute should be 0.2 plus 0.2 equals 0.4 mole. Okay, so that's obvious. And the volume, of course, you can see it should be the volume of the first solution plus the volume of the second solution. Okay, so when we do calculation, it should be, here is a typo, okay, so it should be 0.4 plus 0.4, which will give you 0.8 dm cube. Okay, so again, that's quite straightforward. However, can we do the same for molarity? Should we just add the molarity of the first solution and with the molarity of the second solution and get the final molarity of the resulting sodium chloride solution? Is it equal 0.5 plus 0.5, which is 1? Okay, so here you can see I put a not equal sign here, but why? What is the reason for that? Okay, so if we do proper calculation step by step, we could work out the correct answer. Okay, so we know number of moles should equal volume, molarity multiplied by the volume. Okay, so here we have worked out the number of mole is 0.4. Molarity is the one that we want to work out, and then we know the volume for sure is 0.8. So the molarity in terms of the number solute and the volume of the solution should be 0.5 molar. So it actually stays the same. Okay. So imagine a real life example. For example, if I buy a single espresso, okay, the coffee for you, and let's say teacher Laura buy you another cup of single espresso for you. You are just having 2 cups of single espresso, okay, a larger size, but you're not going to get a single size of the double espresso. Okay, the concentration didn't change, the molarity didn't change. You are just getting a larger size of the coffee. Okay, so that's exactly what we are talking here using a sodium chloride solution. Okay, so whenever you are mixing the two solutions, never just directly add the molarity, but you need to follow the formula and do it step by step to work it out. Okay, again, let's try the example here. Okay, so here we got 150 cm cube of 3 molar sodium chloride solution. Okay, that's our solution 1. Again, you can use a highlight pen to highlight the detail. Okay, and then it's mixed up with 50 cm cube of 1 molar sodium hydroxide solution. And what is the concentration of sodium ion in the resulting solution? Okay, so here, let's circle the part we need to do unit conversion first, okay? And then let's work out the total number of mole of sodium ion. So in the first example, we have sodium chloride solution, molarity multiplied by the volume. So molarity we got 3.0, and the volume, it should be 150 multiplied by 10 to the power of minus 3. Okay, so the resulting number of mole should be 0.45 mole. That's for the sodium chloride solution. And then for the second solution, we have sodium hydroxide solution. Okay, so sodium hydroxide solution, molarity is 1.0, and then the volume we got 50 cm cube. Again, convert it into dm cube, so times 10 to the power of minus 3. So it will give us 0.05 mole of sodium ion. So the resulting solution should have 0.45 plus 0.05, which is 0.50 mole of sodium ion. The resulting volume of the solution, easy, it should be 0.15 plus 0.05, so which is 0.2 dm cube. Okay, so the molarity should be equal to the number of mole over the volume. So it should be 0.5 over 0.2. Okay, so the final molarity should be 2.5 molar. Okay, and take a look at the second example. It starts to get a little bit complicated, so pay special attention. Here we got solution X is prepared by mixing 100 cm cube of 2 molar sodium sulfate with 50 cm cube of 1 molar sodium nitrate. Okay, so what is the molarity of sodium ions in X? Okay, here, remember in Unit 12, we spent quite a lot of time discussing how much atom or how much ion will be released for 1 formula unit. Okay, so here for sodium sulfate, for 1 formula unit, it will release 2 sodium ion. Okay, so after we work out the number of mole for sodium sulfate, we need to multiply by 2 in order to work out the number of mole of sodium ion it can release. Okay, but for sodium nitrate, because 1 formula unit of sodium nitrate will only release 1 sodium ion, so there's no need to multiply by another coefficient. Okay, so here, that's the key. That's because these 2 represent that each formula unit of sodium sulfate will release 2 sodium ion in it. Okay? And the number of mole of sodium sulfate here, it will be 2 the molarity times the volume. Okay, in cm cube we convert it into dm cube, so it will be 100 times 10 to the power of minus 3, and remember, multiply by 2. Okay, multiply by 2. That's because this subscript here, okay, contains 2 sodium ion. Okay, and then it needs to plus the sodium ion released from sodium nitrate, so it will be 1 multiplied by 50 cm cube, convert to dm cube, so it will be 50 multiplied by 10 to the power of 3 minus 3. Okay, so that will give us the total number of mole of sodium ions, which is 0.45 mole. And the volume of the solution, so you just add the volume of the 2 solutions, so 100 cm cube plus 50 cm cube, so in total 150 cm cube. Okay, and you can convert the unit here, so it will be 0.15 dm cube. So the molarity should be number of mole divided by the volume, so it will be 0.45 mole over 0.15 dm cube. So the final answer should be 3 molar. Okay, so every time you are given a substance, please write out its formula, okay, and then work out how many ions or how many atoms it will release. Okay, how many it should be how many ions that it will release when dissolved in water. Okay, it must be ionic compound, so it will release the ions. Okay, again, up to the checkpoint questions. Now you can pause the video and try those 3 questions. Okay, so let's go through those questions together. The first one, again, I suggest you to use highlight pen to distinguish the 2 solutions. The first solution, we have 50 cm cube of 0.6 molar of iron 2 sulfate. In the second solution, we got 150 cm cube of 0.2 molar of iron 2 nitrate solution. Okay, so we need to first work out the total number of iron 2 ions. So remember, because we're having more ions in it, so better have a subscript to represent which one you are calculating. So the total number of mole of iron 2 ions would be, okay, the molarity of iron 2 sulfate times the volume of iron 2 sulfate plus molarity of iron 2 nitrate multiplied by the volume of iron 2 nitrate. Okay, and then we substitute those numbers in. So 0.6 multiplied by 50 times 10 to the power of minus 3. Okay, and then plus 0.2 multiplied by 150 times 10 to the power of minus 3. The final answer should be 0.06 mole. Okay, and then let's work out the volume. Okay, so the volume will simply be the sum of the two solution. Okay, so it will be 200 cm cube. And remember, we need to convert it into dm cube, so 0.2 dm cube. And then the molarity gonna be the number of mole over the volume. Okay, so 0.06 over 0.2. So the final answer would be 0.3 molar. Okay. And then let's move on to question 2. Okay, question 2. We have 20 cm cube of 1 molar sodium chloride mixed with 10 cm cube of 2 molar sodium carbonate. Okay, here I want you to pay special attention. For sodium carbonate, you can see a subscript after sodium. That means each formula of sodium carbonate will release 2 sodium ion. Okay, each formula unit of sodium carbonate will release 2 sodium ion. So when we are calculating the sodium ions that can be provided by sodium carbonate, we need to multiply by 2. Okay, so let's write it out. So the number of mole of sodium ion should equal to molarity of sodium chloride multiplied by the volume of sodium chloride. Okay, and it's okay, each formula unit of sodium chloride just release 1 sodium ion, so no need to multiply by coefficient here. So, and then we'll just plus this number of mole of sodium ion provided from sodium carbonate, number of mole of sodium carbonate multiplied by the volume of sodium carbonate, and remember, multiply by 2. Okay, that's a key. Okay, and then we substitute those numbers in. Will be 1 multiplied by 20 multiplied by 10 to the power of minus 3 plus 2 multiplied by 10 multiplied by 10 to the power of minus 3. And remember, multiply by 2. Okay, the coefficient. Okay, and then the final answer would be 0.06 mole. Okay, and the volume of the sodium ion would be the sum of the two solutions volume, 20 plus 10 equals 30 cm cube, and we can convert the unit here, so it will become 0.03 dm cube. And then the molarity or the concentration would then be number of mole of sodium ion over the volume of sodium ion. So 0.06 over 0.03, which give us 2 molar. Okay? So that's for question 2. Then let's move to the next question in this section. Here we got 10 cm cube of 0.25 molar aluminium nitrate solution, and is mixed with 40 cm cube of 0.1 molar nitric acid. And what is the concentration of nitrate ion, okay, in this resulting solution? So here it just gives you the name of the substance. So better to help you understand the question, you write the formula out first. So aluminium nitrate, the formula should be this. And then the formula for nitric acid, just this. Okay, so to calculate the number of mole of nitrate ion, please pay special attention to this, okay, this subscript. Right, that means each aluminium nitrate ion would release 3 nitrate ion. Sorry, each formula unit of aluminium nitrate will release 3 nitrate ion. Okay, so when you're calculating the number of mole, you need to multiply by 3. Okay, so let's write it out. Number of mole of nitrate ion should equal molarity of aluminium nitrate multiplied by the volume of aluminium nitrate multiplied by 3. Okay, so that's a key, don't forget it. And then it should be plus the molarity of nitric acid multiplied by the volume of nitric acid. Okay, so we substitute the numbers in. 0.25 multiplied by 10 times 10 to the power of minus 3 multiplied by 3, and then plus 0.1 molar multiplied by 40 multiplied by 10 to the power of minus 3. Okay, and the final answer should be 0.0115 mole. And then the volume. Okay, we'll just add them up. It should be 10 plus 40, so 50 cm cube. And we convert the unit here, so it will be 0.05 dm cube. Okay, and the molarity of nitrate ion here would become number of mole of nitrate ion over volume of nitrate ion. Okay, so 0.0115 over 0.05, which give us 0.23 molar. Okay. For this example, we have sodium hydroxide, which reacts completely with sulfuric acid. Okay, so the resulting product would be sodium sulfate and then plus water. Okay, this is a neutralization reaction. And what we have in the question provided for us is the volume of the sulfuric acid used, and the volume and the molarity of sodium hydroxide solution. So from the information given in the question, we will be able to work out the number of mole of sodium hydroxide used in the reaction. And remember, in Unit 12, we have learned the molar ratio. Okay, so by using the ratio provided in the equation, then we can work out the number of mole of sodium sulfate produced, and the volume would just be the volume of the two solutions add up. Okay, so that we could work out the final concentration of the sodium sulfate solution. Okay, so let's try to work it out. So the volume of the resulting solution would just be 100 plus 50. So it would be 150 cm cube. If we do the unit conversion, then it will become 0.15 dm cube. Okay, and then the next part, we calculate the number of mole of sodium hydroxide. So it would be the molarity of the sodium hydroxide multiplied by the volume of the sodium hydroxide. Remember, we need to do unit conversion. Okay, so molarity 1.0 and the volume, okay, is 100 multiplied by 10 to the power of minus 3. Okay, so it will be 0.1 mole. Okay, so from here, if we know the number of mole of sodium hydroxide, how do we work out the number of mole of sodium sulfate? Remember in Unit 12, I told you the way to work it out, okay, is to divide it by others and multiply by yourself. So others is the one that you know. So in this case, will be sodium hydroxide. Okay, and the one that you want to work out is yourself. So you are sodium sulfate in this question. Okay, so you should divide it by others coefficient, which is 2 here, and then multiply by your coefficient, okay, which is 1 in this case. Okay, so okay, by reading the equation, we know that the molar ratio between sodium hydroxide and sodium sulfate is 2 to 1. Okay, so the number of mole of sodium sulfate would be 0.1, okay, divided by others coefficient and then multiplied by yourself. Okay, so that will give you 0.05 mole. Okay, remember, divided by others, multiply by yourself. And then now we have number of mole of sodium sulfate, and we also have the volume of the resulting solution. Okay, so now easy for us to work out the molarity. So it should be number of mole 0.05 over the volume, which is 0.15. Okay, so the resulting solution's molarity will be 0.33 molar. Okay. If we move to the checkpoint questions, now you can pause a video here. Okay, so let's go through the checkpoint questions together. The first one, consider the following equation. So calcium nitrate react with sulfuric acid to produce calcium sulfate plus nitric acid. So excess dilute sulfuric acid is added to 10 cm cube of 1 molar calcium nitrate solution. And what is the theoretical mass of the calcium sulfate obtained? Okay, so the question gives us the volume of calcium nitrate and also the molarity of calcium nitrate. Okay, so if we multiply these two, then we will get number of mole of calcium nitrate. Okay, and then if we know the number of mole of calcium nitrate, then by using the molar ratio, we will be able to work out number of mole of calcium sulfate. And then we will be able to work out the molar mass, and finally work out the mass of the calcium sulfate obtained. Okay, so let's work out the number of mole of calcium nitrate first. Okay, remember, since we are calculating different substance here, so it's essential for you to have the subscript indicating which substance you are calculating. So here, I'm calculating the number of mole of calcium nitrate first. Okay, so it should equal to its volume multiplied by its molarity. So it should be 10 times 10 to the power of minus 3 multiplied by 1. Okay, so it should equal to 0.01 mole. And then because it's 1-to-1 ratio, or you can say divided by others, which is 1, and multiply the coefficient of yours, which is 1 again. So there's no change. Okay, so you can say because the molar ratio is 1-to-1, so we know the calcium sulfate number of mole is equal to 0.01 mole as well. Okay, and then the next step, we need to work out the molar mass of calcium sulfate, okay, which equals 40.1 plus 32.1 plus 16 multiplied by 4, okay, which gives us 136.2 gram per mole. Okay, and finally we will be able to work out the mass of calcium sulfate, which equals number of mole multiplied by the molar mass, which is 0.01 multiplied by 136.2. Okay, and it will give us 1.36. Okay, 1.362 gram. Okay, that's for the first question. And now let's move on to the second question. Question 2. 25 cm cube of 0.2 molar sulfuric acid are completely neutralized by 15.5 cm cube of sodium hydroxide solution. And what is the concentration of sodium sulfate solution formed? So for this question, the equation is not given. So first step that you need to do to solve this question is to write the balanced chemical equation. Okay, so sulfuric acid is react with sodium hydroxide, and then it will form sodium sulfate plus water. Okay, so a neutralization reaction. Okay, remember you need to balance the equation, otherwise you won't get the correct molar ratio. Okay, and you need to write the state symbol as well. Okay, so now let's fill in the part that the question have provided for us. So for sulfuric acid, in mentioning the question, the volume is 25.0 cm cube, and the molarity is 0.200. Okay, and for sodium hydroxide, the volume is given, which equals 15.5 cm cube. Okay, and the molarity didn't mention here. And what we are looking for is the molarity, okay, of the sodium sulfate solution formed. And we know the molarity should be calculated by using number of mole divided by its volume. Okay, so how can we do it? So using the information provided in the question, we got the volume, we got number of mole, so we should be able to work out the number of mole of sulfuric acid first. Okay, so let's do it. So for sulfuric acid, remember to have the subscript in the bracket should equal to its volume multiplied by its molarity, and then substitute the numbers in. So 25 times 10 to the power of minus 3 multiply 0.200, okay, which will give you 5 times 10 to the power of minus 3 mole. Okay, so here we can use a molar ratio given in the equation. Okay, so the mole ratio between sulfuric acid and the one that we want to work out, which is sodium sulfate. Okay, according to the equation, the molar ratio should be 1-to-1. So we know the number of mole of sodium sulfate formed should also equal to 5 times 10 to the power of minus 3 mole. Okay? And then you can also think like this. Okay, you are the one that you want to work out. Okay, so you should divide it by the coefficient of others, the one that you know, okay, and then multiply by the coefficient of yours. So divided by 1, multiplied by 1, so it stays the same, 5 times 10 to the power of minus 3 mole. And then, okay, now we know number of mole. We need to work out the volume, okay? So the volume should be the volume of sulfuric acid plus the volume of the sodium hydroxide we add in. So the volume of sodium sulfate should equal to the volume of sulfuric acid plus the volume of sodium hydroxide. So it will be 25 plus 15.5, which gives you 40.5 cm cubed, and we do unit conversion, it will become 4.05 times 10 to the power of minus 2 cm cubed. Okay, so now we know number of mole, we know the volume, so we will be able to work out its molarity. So molarity of sodium sulfate that formed should equal to the number of mole of sodium sulfate over its volume. So it should be 5 times 10 to the power of minus 3 and divided by 4.05 times 10 to the power of minus 2, okay, which equals 0.12 molar. Okay? And the last question, question 3. Okay, for this one, again, we use the highlighter to help us distinguish the information we are given. We have 0.2 molar dilute hydrochloric acid that reacts with 25 cm cube or 0.4 molar calcium hydroxide solution until complete neutralization. So what is the concentration of the calcium chloride in the resulting solution? Again, there is no equation, so let's write the balanced chemical equation first. Dilute hydrochloric acid reacts with calcium hydroxide, and it will form calcium chloride and plus water. Right, remember to balance our equation and then write the state symbol. And then we can fill in the information that we know from the question. So we know the molarity for hydrochloric acid, 0.200 molar. And for calcium hydroxide, we know the molarity, 0.400 molar. And we also know the volume of calcium hydroxide, 25.0 cm cube. And what we're looking for is the concentration of calcium chloride. Okay, and we know to work out the concentration, we need to work out number of mole, and we also need to work out the final volume. So let's figure it out step by step. So first, let's work out the number of mole. Again, in order to work out the number of mole, we need to use the given information for calcium hydroxide. So for calcium hydroxide, we know the molarity, we know the volume. So we should be able to work out the number of mole. And then we use the molar ratio given in the question so that we can work out the number of mole of calcium chloride. Okay, so the number of mole of calcium hydroxide should equal to its molarity multiplied by its volume. So it would be 0.400 multiplied by 25 times 10 to the power of minus 3, okay, which would be 0.01 mole. And then we know the mole ratio of calcium hydroxide to calcium chloride is 1:1. Okay, 1:1. So the number of mole of calcium chloride should also equal to 0.01 mole. Okay, so that's the first part of this question. We have worked out the number of mole. So the second part is the key, okay, and the tricky part in this question. We need to work out the volume. Okay, unlike the second question, it tells you how much acid it has been added. This time we are given the molarity, but we didn't know the volume of the acid needed. However, in the question, it gives us a hint. It said until complete neutralization. Okay, so complete neutralization, that means we can again using the molar ratio. Okay, it means it just reacted in the accurate amount. No hydrochloric acid is left. Okay, it's not in excess, just the right amount. So how do we work out the right amount? Okay, so again we are going to use the number of mole of calcium hydroxide we found out. Okay, and by using the molar ratio we will be able to work out number of mole of hydrochloric acid needed, okay, to neutralize those calcium hydroxide. And then if we know the number of mole of hydrochloric acid and we know the molarity, so we could work out the volume of hydrochloric acid used. Okay, so let's write it out. Because we know the molar ratio of calcium hydroxide to hydrochloric acid is 1:2. Okay, so the number of mole of hydrochloric acid, okay, that's yourself, so it should be divided by others multiplied by your coefficient. So divided by others, 0.01, divided by others multiplied by yourself, so it should be 0.02 mole. Okay, and then if we know number of mole, we know molarity, so the volume of hydrochloric acid should equal to number of mole of hydrochloric acid over molarity of hydrochloric acid. So it should be 0.02 over 0.200 molar, which will give you 0.1 dm cube. Okay, so from here we know the volume of hydrochloric acid, we know the volume of calcium hydroxide, so the final volume of the solution, okay, which is a calcium chloride solution, should be the volume of hydrochloric acid plus volume of calcium hydroxide. Okay, so it will be 0.1 plus 0.025. Okay, so it's 0.125 dm cube. Okay, so now we have worked out number of mole, we have worked out the volume for calcium chloride, molarity. Okay, we just need to do one more step. So the molarity of calcium chloride should equal number of mole of calcium chloride over the volume of calcium chloride. Okay, so it will be 0.01 over 0.125, which will give you 0.08 molar. Okay,